Alright, my name is Dalton Halbig, and I had problem 4 from the Expert TA. This was looking at a couple different components. There was a diagram that went with the problem at the very beginning, and that is what is drawn up here. It was a block sitting on a table with two separate forces acting on it, one in the X direction and one in a kind of diagonal direction. Then we had the origin of X and Y. So with that diagram, it asked for the free body diagram that showed the forces acting on the block. So if we look at it, we have a few forces. We have the given forces. So F1 is going to be acting in the horizontal direction right here. Then we have the F2, which is acting right here and coming in the diagonal direction with a angle, and the angle being theta of the X plane. So it's going to have a different angle to it. And then these weren't given forces, but these can be assumed forces. So we had the force of gravity keeping the block on the table, and then we had the normal force, which is the force of the table, keeping the block up and off the ground. So that's the free body diagram. Then we go and we look at part B. Part B was asking for us to find the net forces in the X direction. So if you look at these net forces, you're going to have two forces that are actually acting on the block. So you have the given F1 force, that's for sure. And then the F2, so if you just push the block this with its diagonal force, the block would move this way in a general fashion. So that means that there's two forces in the X direction, but it would want to know what the full force of that is going to be. So you would take the F2 cosine and minus that by the F1 force. The F2 cosine will reduce that F2 force, and generally, as long as the F2 force isn't massively greater than the F1 force will actually overpower the F2. And then we look at the part C of this problem, and this was asking for the total net force of the F2 force and all the forces that are applied with it. So it's looking for, when you look at the mass of the block, gravity, the force, and the angle against resistance as well, what is the total of that force going to be when you're applying that F2 force? So when you look at it, you're going to have the F2 force, and it's going to again be by sine theta. Not again by sine theta, but it's going to be by sine theta this time. And then you're going to have adding the mass and the gravity together of the block, and that'll give you the total force whenever the force of F2 is applied.